Let's discuss some of the questions based on motion in a straight line. Okay. Here, in the first question, they have said that we need to find the numerical ratio of distance to displacement. Sorry, the numerical ratio of displacement to distance is. We know that displacement is the shortest distance, and distance is the actual path. So we also know the condition that distance is always greater than or equal to displacement, which implies displacement divided by distance is always less than or equal to 1. So the correct option is option 4. Let's go on to the next question. Here they have said that if the displacement of the particle is 0, this is the first question. If the displacement of the particle is 0, then we need to find that what is the distance traveled. Distance is equal to question mark. Yeah. If the displacement is 0, we will get to know that the object has returned to its original position. Then, if the object had returned to its original position, displacement will be 0. But the distance will never be 0 and negative. So, the distance will not be 0. Let's take an example. If an object had gone from A to B, had moved from A to B, and it had returned to A again. So here the displacement will be 0, but the distance covered will be AB plus BA. By this we can say that if the displacement is 0, then the distance travelled need not to be 0. The second option is correct. Let's go on with the third question. Let's go on to the first question. Next question. Area under the acceleration time graph. We know that acceleration is equal to change in velocity by time, which implies if we rearrange the equation, we will get change in velocity is equal to acceleration into time taken. So area under the acceleration time graph gives change in velocity. So option 3 is the correct answer. In the next question, the displacement time graph of the particle in the motion shows that the instantaneous velocity of the particle is negative. We need to find in the graph. We need to find at which point the instantaneous velocity is negative. Here in the graph, when the body is moving from 0 to C, the velocity is increasing. From C to D, also the velocity is increasing. But when the body is moving from D to E, the velocity is decreasing with respect to time, and from E to F, it is again increasing. But at point E, we can say that the velocity is almost decreased with respect to time. So at point E, the instantaneous velocity will be negative. So option 4 is the correct answer. So next question. A particle starts from rest to move in a straight line when an opposite force tries to stop it. Then what will be its condition? Let's take an example, like if we throw a ball to a wall, then the ball bounces back and comes to us. But the ball will not take the same path which we had thrown. It may change its direction or it may change its path. By this, we can say that, give the answer that the body is going to change its path when an opposite force tries to stop it when it's moving in a straight line.